All right, this is going to be page 33 of math analysis, and we are in the middle of notes 4, and we're talking about reference angles, and we just filled in this page, and if you were paying attention during that page, you got a good idea of what's going on here. So let's take a look. So let this thing catch up. Here it goes. Now it goes back. There we go. All right. So what we want to do is take a look at these. And it starts off with summarize what you just found by filling in the statements below. All right, so it's always bothered me that for whatever reason, the way I made this, like this underlining here kind of like got to be a little too like white. That has always bothered me. I don't exactly know why this has happened. Oh, that one, I fixed that one pretty good. So bear with me like 1 second here. I'm just trying to fix this. Move it up a little bit. I don't know. I tried. That's not great. All right, so 120 degrees is basically a 60-degree angle in quadrant 2 because you're 60 degrees short of 180 and you're measuring to the closest part of the x-axis, and that is the negative x-axis. So you're 60 degrees short of where you want it to be. So the next angle that we're interested in then is going to be, 135 degrees. And 135 degrees is basically a 45-degree angle, and that is also in quadrant 2. I'm going to do the quadrants last. And then 150 degrees is basically 30. We skip 180 because it's quadrantal, and it's not in a quadrant, and it doesn't have a reference angle. So 210 degrees is 30. 225 is going to be 45. 240 is going to be 60. We skip 270, then we go to 300, which is 60, and then 315 is going to be 45, and then 330 is going to be 30. Okay, so because so in the second quadrant you're always over 180 by whatever amount. In the third quadrant you're always what am I saying here? In the second quadrant you're always short of 180, right? So 120 is 60 degrees short of 180. In the third quadrant, you're always over 180 by a certain amount, right? So 225 is 45 degrees more than 180. In the fourth quadrant, you're always short of 360. So 330 is 30 degrees short of 360. So the reference angle is 30. So we need to kind of work that out. And then here, 2, and then 3, 3, 3. You get 3 in each of the famous ones. I mean, there's actually an infinite number in each. I forgot my, what? I'm just writing TV. There we go. 1, 2, 2. There. You want to be consistent with the way you incorrectly draw those fours. So these are the famous ones. And let's see if we can work out what was happening there. So I need to come up with formulas. So in the second quadrant, first quadrant, by the way, the angle just is its reference angle, so you don't really need to do anything. That one's kind of done for you. Here, these were all quadrant 2. Right, these were quadrant 2. And to figure out the reference angle, basically what we did was we said, like, how far short of 180 are they? So up here, we basically did 180 minus, let's call it x, or theta. Let's call it theta. And it gave us the reference angle. So we need a notation for that. So the notation that I'm going to use is going to be theta prime. So prime is, it just looks like an apostrophe. Later in life, you're going to use prime for something else also, but it'll never really be ambiguous, so you don't really need to worry about that. So theta prime, the reference angle, just 180 minus the angle. Now think about in quadrant 2, 3, what is happening? So this was quadrant 2. I feel like I just keep messing up the quadrants. This was quadrant 2. Now I'm going to talk about quadrant 3, which I almost messed up again. Okay, so we're talking about how far over 180 are we? So if we take the angle that we know and we subtract 180 from it, that should give us our reference angle, theta prime. And then in the fourth quadrant, we were saying that basically we want to figure out how far short of 360 did we fall. So 360 minus 300 is 60, 360 minus 315 is 45, 360 minus 330 is going to be 30. So in general, in quadrant 3, we can do 360 minus whatever theta is will give us theta prime, the reference angle. So let's go down here and write our formulas. So in quadrant 1, the angle and the reference angle are actually the same. So there's really like kind of nothing to do. So I'm going to say here, theta prime, the reference angle, is just equal to theta. Nothing exciting about that one. And we don't even need to distinguish radians and degrees. Let's take a look at the next one. So here, theta prime is going to be, so how far short of 180 are you? So that's 180 minus theta, or in radians, theta prime would be pi minus theta. Okay, and you do a lot of these in degrees, to be honest. It's not that it's not important to do it in radians, it definitely is. But I think because the math works out a little easier, you do degrees more. I don't really know. Quadrant 3, how far over 180 were you? So theta prime is going to be how far over 180. So theta minus 180, or we could say it's theta prime is theta minus pi. And then quadrant 4 is like the weird one because you're talking about how short of a full revolution are you? So instead of using just pi, you're gonna have to use 2 pi. It's like a little weird. So theta prime is gonna be 360 minus theta, or theta prime is 2 pi minus theta. Whichever one you think is more convenient. All right, so although that wasn't too much, I think I'm going to stop the video here and come back in the next one and finish this page, because the next problems, to do them right, requires like a little bit of discussion. So I will be back in the next video to finish this page, and I will see you there.